Good evening, all of you, and welcome to this session. Hope I am audible.
Yeah.
Yes.
Good evening, sir.
Yes. Yeah.
Good evening, sir.
Yes. Yeah.
Good evening, sir.
Uh, uh, all right. Hope my screen is visible. 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 Right. Hope my
Sir, your voice has an echo, like it's repeating.
Is it better now?
Yes, sir, it's not repeating right now.
Better, right? Now the echo is not there, right?
Sir.
Okay. All right. So today we will be discussing week 3 once again, finally. Right. So if you have any doubts, anything related to concepts or from the problems or anything till week 3, this is the final chance that you get. Okay, so please put forward your questions and we will discuss. If there are multiple questions, just raise your hands. I will call out your name and then in order we will proceed. Okay. Yes, Tanya.
Hi sir, I actually had doubts regarding tutorial 4 of stats. That question in week 3.
All right, so let me see. Week 3 tutorial 4, right?
Yes sir.
Did you go through the video, complete video?
Yes sir, but I couldn't understand that much.
Okay, all right. Let me just see the question. Okay, so is this the question just to confirm the mean of 25 observations is 36? The mean of the first 13
Yes,
observations is
this one
32.
only.
Right, so great. So let's do that. We'll start with that then. So this is week 3, tutorial 4. Okay. And this question says, mean of 25 observations is 36. Right, so this is all the observations mean. And the next information that is given to us is mean of the first 13 observations is 32. Right, and the next information given to us is mean of the last 13 observations is 39. Now the question is, what is the 13th What is the value of the 13th?
So, excuse me, sir.
Yes.
So, what will you discuss today on this? I joined
Uh,
late.
okay, so nothing much. So I will be taking doubts. So it's like an once and for all. This is the final session for week 3. So if you have any doubts related to week 3 concepts or any problems related to week 3, you can ask and we will discuss.
Okay. Okay.
Okay, so that's the agenda for today.
Okay. Thank you so much.
Okay. All right, so this is the information given to us, and this is what we have to find. Right, so given the information, we will write it in mathematical equations or mathematical form. Right, so there are 25 observations. Let's label them.
I have a doubt in mock.
Just hold on. We'll go one by one, as I said. Right. So after this, please raise your hands if you have doubts. I will call out your name and you can raise your question and we'll discuss that and move forward to the next person. Okay. So those who have doubt, just raise your hands in the Zoom. Okay. So since there are 25 observations, we label it. Let's say x1, x2, x3, and so on, x25. Right. So let's say these are the 25 observations that we have. From the first information that is given to us, we have the mean of these 25 observations is x1 plus x2 plus x3 and so on plus 25 divided by 25 is the mean, right? So this is the mean. And this is given to be 36. From here, I can get the sum of the observations, all the observed, which is 25 times 36. Correct? Just keep this aside. Okay. So this is one. And we also have other informations also. So the second information is mean of the first 13 observations. Firstly, we have to identify what are the first 13 observations are. What will be the first 13 observations? They are x1, x2, x3, and so on till x13 are the first 13 observations. Right, so these will be our first 13 observations, right? So the mean of these first 13 observations, mean of first 13 observations. Right, so what will be the mean of this first 13 observations? X1 plus x2. So the sum of the data point values divided by total number of data points will be the mean, right? So divided by 13. This is also given to be
32.
32. So if you equate it to 32, then you have the sum of the first 13 observations, which is 13 times 13. So you say the previous one to be equation 1. You call this as equation 2. And still there is third information for us. The mean of the last 13 observations is also given to us. Firstly, identify what are the last 13 observations are. Correct. So what are they? The last 13 observations, you see that it is x25, x24, x23, x22, and so on till where will you reach? X14 or x13? Will reach x14 and x13. So these will be the last 13 observations. Right? So you can count 13, 14, 15, 16, 17, 18, and so on till 25, you will reach 13 observations. So these are the last 13 observations. And this mean also is given to us, mean of the last 13 observations. This is the last. I hope you can read my
Yes, sir.
It's readable, I guess, right? So now this is like x25 plus x24 plus x23 and so on, x14 plus x13 divided by 13, because total number of data points here are 13, the last 13 observations, and sum of them divided by 13 will give us the mean, and the mean is given to be 39.
39.
And from here we can get the sum of the last 13 observations, which is x25 plus x24 plus x23 and so on, x14 plus x13 is equals to 13 times 39. Just number this equation also as 3. So now we have 3 equations with us. One is sum of all the 25 numbers, right? So all the 25 data points. In the second equation, we have the sum of the first 13 observations or the data
This
points.
is correct.
And the third equation, we have the sum of the last 13 observations. So from here, we need to find x13.
13th observation.
X13th observation is what? x13 is, right? So we need to find. So we have, I'll write all the things together, what all we have. So we have this whole sum as sum 25 times 36. And we have x1 plus x2 and so on plus x13 as 13 into 32. And then we have x13 plus x14 plus and so on till x25 as 13 cross 13. So now can I do something with these 3
Yes, sir.
equations so that I can get x13? What can I
Yes,
do?
sir. So, the total numbers, the total sum of the first 13 observations and the last 13th observation is the sum of the all the 25 observations plus the 13th observation.
Very good. So if I just add these 2 equations, right? So the last 2 equations, if I just add them, I'll have the sum of all the observations, but you see x13 is added twice. So I'll have sum of all the observations, then an extra x13 separating. And I know this sum from equation 1. And this is like 13 cross 32 plus 13 cross 39 on the right hand side. On the left hand side, we will have all the observation sum. Along with that, we will have one more term, which is x13. Now what I know this value from equation 1, I substitute. I'll just substitute. I'll just have 25 times 36 plus x13 is equals to 13 times 32 plus 13 times 13. From here, we can get our 13th observation, which is x13, as 13 into 32 plus 13 into 39 minus 25 times. And I think you can do that computation and you'll end up getting the correct answer. Clear? Is this okay?
Yes, sir.
Okay, all right. Nice. So, next question, please.
Sir, may I?
Yeah, but I see nobody has raised their hand, so you can go ahead.
Okay, thank you, sir.
Yeah.
So my question is more on concept based.
Hmm.
Median, like when it is dependent on the number of observations, whether they're even or odd.
Hmm.
But when we move to percentile, we say that 50th percentile is the median.
Correct.
So, and when we calculate the quartiles,
Hmm.
We don't see the number of observations.
Correct.
So, how this statement is always true that 50th percentile is median, because 50th percentile is not dependent on the number of observations.
Oh, that's a good question. So it is said that 50th percentile is like uh, median in a general sense. Okay, so like usually median is what? The middle observation, right? Middle one,
Yes, sir.
right? So in that sense, even the 50th percentile is like 50% of the data is below that data point.
Yes, sir.
Correct, right? So in a general sense, in most of the cases, 50th percentile is said to be median, but it is not very well written, or it is not too sacred to say like that.
Mm-hmm. Okay.
Got it, right? So in a general sense, 50th median, the definition is the middle data point.
Correct.
50th percentile is also something that which is at the middle. So in
Mm-hmm.
that sense, median is said to be the 50th percentile. If it is odd, then there is no issues at all.
Correct.
The issue will come only when it is even.
Yes,
So
sir.
in even cases also, we kind of 50th percentile, we have to choose a data point, not the middle value. But for median, we can't take a data point. We have to take the average of the middle points, right? So that difference will come. That's it.
But sir, if like for example, if any question asks median as well as the 50th percentile,
Hmm. Uh,
what should
me,
be our answer then?
got it. So I'll just take an example and say
Okay, sir.
far better than. Okay, so let's say you have a data point 16, 10, 12, 14, 20, and 100. Okay, so first of all, if you have to compute Q1 or Q2 or Q3 or median for all these things, the first and foremost thing that we have to do is to write them in ascending order.
Yes, sir.
Okay, so if I write this them in ascending order 10, 12, 14, 16, 20, 100. So since there are 6 data points, median will be the average of the third and the fourth one,
Yeah.
right? Median is 14 plus 16 by 2, which is 15. Correct, right? So median is basically like the middle, exactly at the middle.
Yes, sir.
Whereas when we come to the percentiles, no? So usually percentiles is like, if I say p percentile, it means that p% of the data lies to the left or lesser than the data point,
Yes, sir.
right? So here 50% is exactly in the middle,
Yes, sir.
right? So there is no data point labeled 15 in the data set to say that is the 50th percentile data point, right?
Yes, sir. So we'll take the 16th one.
We will
Like,
take the 16th one and say that is the 50th percentile.
yes, sir.
So for percentiles, we have to choose the data point. Whereas for median, it need
Okay.
not be the data point. It is just the center value, exactly the center value. So that's the difference. Okay. So if we ask for 50th percentile, you have to compute the 50th percentile. If you ask for the median, and then you have to compute the median.
Okay.
Okay.
Because in general, like we have heard that median is the middle, but actually it is not.
Median may not be a data
Same as,
point,
yeah.
but whereas percentiles should be a data point.
Yeah, one difference is this, and secondly, it is that 50th percentile actually will not be exact midpoint. It may like it
Ah.
will be one more than
One more then, correct.
Okay, sir. Okay,
All
sir.
right.
So
Okay.
accordingly, we'll take the quartile.
We have to
and,
compute. Yeah, correct.
Okay, sir. Thank you so much.
Yeah,
sir.
thanks. Yeah, Arnab Singaroy.
Yes, sir. Yes, sir.
Yeah.
I have a doubt from activity question from 3.5 question number 8, 9, and 10.
3.5.
Yes, sir.
Okay.
Excuse me, sir.
Yeah.
Sir, I have a little doubt about the percentile. What you discussed in last minute.
Okay. Meanwhile, I will take some time also to open the 3.5. You can go ahead, Alok. What
Sorry,
doubt you
sir.
have? Yeah, you can go ahead. You can ask
Okay, okay.
what doubt you
Sir,
have.
sir, I have a little doubt about when we studied about the percentile, right?
Hmm.
And see the whole data set, I mean, see the whole observations, okay?
Hmm.
Then there is some outliers, okay?
Hmm.
And after the percentile, we also studied about the IQR, I think IQR, something
Interquartile
like this.
range. Yeah.
Yeah. Yeah. Then after that, there's a concept about the finding the outliers,
Correct.
and it has some formula like something Q3 minus and all like this type of thing.
Correct.
So, sir, please describe this formula. How can I calculate the outliers and all?
Okay. So, okay, I will discuss that. But that is something beyond this, whatever I discussed just now. Just hold on.
Mhm.
Let me handle Arnab Singh Roy's question and I'll just come back to this. And I will take
Okay, so
a nice data set and we will do compute mean, median, mode, and then we will also compute this Q1, Q2, Q3, and then we will compute this interquartile range again, and then finally we will also find outliers. So one example I will take so that
okay,
everything will be clear. Okay.
yeah, okay, okay, sure, sir.
Okay. Okay. This activity 3.5 is
Yes, sir.
basically on this box plot, right?
Yes, a box plot.
So you know how to read block plot?
No, sir.
No. So it says, so you see the thin lines, right? Thin lines on vertical lines above the box and below the box, right?
Yes, sir.
It basically says the data is centered or concentrated more in this region.
In
Okay.
the rectangular region.
Rectangular region. Like it is starting like Q1 and the maximum value that you see is the Q3. So the bottom box line is Q1 value, whatever you see at the value will
So
be
I think
Q1.
it's 18 something.
18 or approximately 19. That is why they said they didn't ask the exact value. They asked an approximate value,
Yes, sir.
right? So approximate is like, we know it can be 18 or 19, but from the options, if you see, 25 cannot be Q1, right? 52 cannot be, 68 also cannot be Q1.
Okay.
So 19 is among the four options that are given. 19 could be
Nearly
Q.
correct.
Nearly correct. Correct.
Yes, sir.
Okay. So
Sir,
So
yes, sir. That means we need to see the box plot that the most like in this case the rectangular region is the most dense data there, and the thin line basically that is one is at the around I think slightly upper
two
the
or two or three, which tells us the minimum value. See, box plot actually gives us the five summary, right? So five, which is minimum,
yes, sir.
Q1, median, Q3, and maximum. Right. So mostly 50th percentile and maximum.
Maximum is I
Right.
think 68 something will be the
68
maximum.
something will be the maximum. And Yeah, so it actually gives us the 5-number summary,
Yes, sir.
right? So I will just plot it here for you. I'll just write it. Okay, so this is the max value, maximum value. This will be Q3, and the center of this will be Q2. This is Q1, and this will be the minimum value.
Yes, sir.
Okay, so once you know this, so all they are asking is the 8th question is about first quartile value, which is Q1. So we can approximately see this value,
Yes, sir. In this case, it would be 19.
19. Based on the options, it will be 19.
19, yes, sir.
Correct. So this is 19, right? And 9th question is IQR. What is IQR?
So it's Q3 minus Q1.
Q3 minus Q1. So if we can approximately find Q3 value also, if you see it is something like 52, right? 51 or 52.
Yes, sir.
So whichever you take, let's say, let's take 52 itself. Okay. So then 52 minus 90. So approximately around this value should be our IQR. So 52 minus 19 is somewhere around 33. Right. So now you see the options. You can see 25, 33, 19, and 68. So 33
Yeah.
is
Yes, sir.
approximate value of interquartile. And then the range of the data is
Range maximum minus minimum.
minimum. Correct. So if you can find maximum and minimum, so maximum is somewhere in the middle of 65 and 70, which we say 67 point,
Yes, sir.
67.5. And the minimum also, if you say 0 and 5, middle is 2.5.
Yes, sir.
So the range will be 67.5 minus 2.5, which is 65. So even if you take 68, 2.5 or 67, here 3, so you will be within the range. So that is why I think answer should be given in some range. Right. So this will be not exactly 65. It is approximately 65.
Yes, sir.
Okay.
Yeah. Yes, sir. Thank you, sir.
So that's about blocks plot and activity 3.5. 8, 9, and all right. So let's move on to Tanya again. Tanya, you asked your
Yes,
question, right? Do you
yes,
have any
I
other?
have another question.
Okay.
I just wanted to ask that is there any relation between mean and standard deviation?
For computing standard deviation, we need mean, right?
No, no, not like that.
Hmm.
Like I actually had doubt in one question. It's practice assignment 3.1, question number 7. Like these questions, I cannot understand these questions.
3.1, question number.
7.
Okay. All right. So if the mean and sample standard deviation of the date of this particular data are 7 and square root 106 by 6,
Yes,
then the absolute difference between the two data points, x1 and x2, right? So mean, and so it is just the information, right? So there are two unknowns, x1 and x2. So to find those two unknowns, we need two pieces of information, right? So one information is mean value and the other information is sample standard deviation. We will use both of the informations and find x1 and x2. Once you find x1 and x2, then will find the difference and compute the absolute value of that difference. So that's the only thing here. I'll just give you solution skeleton. From there you can build. Okay. So this is PA 3.1, question 7. So the data points are 1, 6, 10, 14, 4, x1 and x2. The information that is given to us are mean of this data is 7. And we know mean is basically you sum up all the data values, data point value, and divide it by number of data points. Right, so the number of data points are 1, 2, 3. So this is the data. So 1, 2, 3, 4, 5, 6, 7. 7. So from here, I can get x1 plus x2. Right, so it is 49 minus 1 minus 6 minus 10 minus 14 minus 4 will be x1 plus x2. So you can compute that value and say that is equation 1 that you have with respect to x1 and x2. Then we also have another information which is standard deviation. Which standard deviation? It is sample standard deviation. So there is a difference between sample standard deviation and population standard deviation, right? I hope all of you know the difference. The sample standard deviation is given to be square root 106 by 6. From here, I know that sample variance right? So sample variance is just the square of the sample standard deviation. So if I just square it, it is 106 by 6. Right? And also I know the sample variance formula, which is 1 by n minus 1. Right? So summation I is equals to 1 to n xi minus the mean whole square. Right? So mean we know, which is 7, and also n we know, which is 7. So both are 7. So if you substitute, so 1 by 6 minus 1 summation I is equals to 1 to 6, sorry 1 to 7 xi minus 7 whole square and this 7. Right, so this is 106 by 6. And you can clearly see that this and this will get cancelled out. And if I expand this summation, we'll have the first data point is 1. So 1 minus 7 whole square plus 6 minus 7 whole square plus 10 minus 7 whole square plus 14 minus 7 whole square. Similarly, like that, 4 minus 7 whole square plus x1 minus 7 whole square plus x2 minus 7 whole square. So all I did was I expanded this summation. I expanded this. And this is basically 106. Right, so now this is 6 square, which is 36, plus 1 square, minus 1 square, which is 1, and 3 square 9, plus 7 square 49, plus 3 square again. So this one 4 minus 7 is 3, 3 square is 9, plus x1 minus 7 whole square, which expanded x1 square minus 2 times x1 times 7 plus 49 plus x2 square minus 2 times x2 into 7 plus 49 is equals to 106. Right, so from here, using the above equation, we can get x1 square plus x2 square as something. Call it equation 2. You can actually use these two equations to get x1 and x2. Right? You can do like that, or the best way to do is, it's like, you understood this?
Yes, sir.
If you understood this, this is like like hard way of doing this. And if we are a little smart, we can clearly see that you can find x1 plus x2, which is 48, 42, 32, 18 minus 4 is 14. Right, so x1 plus x2 is 14. And you have something here, x1 minus 7 and x2 minus 7. So instead of this hard way of doing this, we bring new variables to reduce our work. So we'll say, let's say some L or L to be x1 minus 7, M to be x2 minus 7. So if I treat this x1 minus 7 as some other variable and x2 minus 7 as some other variable, L and M, now you can clearly see that L plus M is basically x1 plus x2 minus 14. Right, so and you have x1 plus x2 is 14, so 14 minus 14 will give you 0. So L plus M is 0 is one equation, and then the other equation you have is this 36 plus 1 plus 9 plus 49 plus 9 plus. Now this x1 minus 7 is L, so this is simply L square plus M square is equals to 106. So we'll have 37, 46, 46, 55, 95, 95 plus 9 is 104. So L square plus M square is 2. So you have L plus M is 0, L square plus M square is 2. So the possibilities are, you just substitute from here, you'll get L is equals to minus M. And you substitute it here, you'll get M square minus M whole square plus M square is 2. You will have 2M square to be 2. From here, M square to be 1. This will imply that M is plus or minus 1. Okay, so once you have M plus or minus 1, your L will also be minus or plus 1. So if M is plus 1, your L will be minus 1. If M is minus 1, your L will be plus 1. So no matter what it is, we don't need M and L, we need x1 and x2, right? So L is x1 minus 7, M is x2 minus 7. So you take any one of the cases, even in the other case also, you'll end up getting the same answer. So for without loss of generality, I take M to be plus 1, M to be plus 1, we take, and L to be minus 1. Then minus 1, x1 minus 7. So from here, x1 will be 7 minus 1, which is 6. And here also, M is 1, x2 minus 7. From here, x2 will be 8. So x1 is 6, x2 is 8. Absolute value, absolute difference between x1 and x2 is 6 minus 8 modulus. So modulus minus 2, which gives us 2. So if you take the other way around, if you take L to be plus 1 and M to be minus 1, then you will get x1 to be 8 and x2 to be 6. And if you take the difference, you will get 8 minus 6, which is 2. And then absolute value of 2 is again 2. So you'll end up getting the same answer. Okay, so this is the best way to do it. But even if you are not okay to go to different variables and solve it, you can directly solve from the two equations that you have and you'll get the answer. Okay.
Thank you, sir.
Okay, so yeah, so we will now take a nice example and then we will talk about the mean, median, everything, mean, median, mode if possible, and then we will also try to plot stem and leaf. Stem and leaf is one good way of representing the data. Okay, so we'll do that, everything together. Okay, so we'll try to cover all week 3 in one example. I'll try. Okay, so let's say I'll just add some context also. A teacher's records 15 exam scores. Okay, so I'll give all the 15 values to you now. Let's take bigger example only. Let's say 12, 15, 17, 20, 25, 18, 85, 30, 27, 22. What else you can do? 24. How many then? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Oh, then 28. Then 30, 32, 35. Done, right? So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Okay, so yeah. Should we do? Okay. We do this. Take this as 30. Then this is 20. All right, so let's say these are the 15 exam scores. Okay. Now let me put out the questions, each sub question. First question is sort the data in ascending order. Okay, so firstly sort this data. And the second question is represent the data using stem plot. Okay. And then represent the data in histogram with the classes 10 to 20, or let me be much more clearer, 10 to 19, 20 to 29, 30 to 39, 40 to 49, 40 above. Okay, so 40 above. Okay, so that is the third one. And the fourth one, compute mean, median, mode, and calculate Q1, Q2, Q3. Okay, so then find IQR, and then compute if there are any outliers using the standard formula that we have, right? In the standard formula. Formula which is outlier. We say outlier if it is less than Q1 minus 1.5 times IQR. We will also say it is outlier. It is greater than Q3 minus 1.5 times IQR. Okay, so if we do this example, no, we are almost covering most of the important concepts of week 3. Okay, so I'll just give you some 5 minutes for the first 3 things. So sorting the data into ascending order is really easy. Represent the data using stem plot and represent the data using a histogram. Okay. Take some time. As I said in the last session, for statistics and mathematics courses, you should definitely have a pen and paper with you. And you should definitely put your pen on the paper, only then you will understand the concepts clearly. Okay, so 6:45, 6:50, I will give you time. Just the first 3 things. If you are done with the first 3 things, then also compute the mean, median, and the mode of the data set. Okay, so let's see. If you are done, just raise your hand so that I will also get to know how many of you have solved it, and if most of you have solved it, then we can straight away discuss the solution. Okay, are you guys trying?
Yes,
Yes,
sir.
sir.
Yes, right. Okay. So once done, please raise your hand so that I will also get to know how many of you have.
Yes, sir. Hello, sir. Hello.
Oh, sorry. I thought I was on mute. Do you have any
Ye-
doubt?
No, sir. I actually am doing this question. Only the till question number 4 is visible. After that, it is not visible. That's why.
Okay. So you are done with question 4 also, is it?
Yes, sir. Till question 4, I actually done.
Okay. We'll go there. Question 5, question 6, and question 7 are just computing Q1, Q2, Q3, finding IQR and outliers. So I said just do till question 4. Okay. Anyway, most of you, I think 1, 2, 3 are fairly straightforward. We can do it, right? So we'll do it now. Let's sort the data. Sorting the data, the minimum value is 12, right? And the next value is 15, and then 17, and then 18, and then 20, and then 20. So 20 repeated twice, then 22, 24. So you just have to write them in the ascending order. That's it. 25, 27, then 30, 30, 30, and then 32, and
35.
30.
5.
No, it's 85.
So there is no 85, I think. Only 35 will be there.
Oh, this is 85, no?
Oh, okay. Oh, sorry, sir.
Yeah.
So done with first 4.
Okay, good. So sorting, I don't think anybody will have any issue, right? So this is how you should sort. You should write, closely observe. See, even sorting also sometimes we kind of miss one data point, right? So there are 15 data points given to us, and while sorting, we will only take 14, or we might miss one. So you should be really very careful, and you just cross verify after you written down all the data points. You just cross verify by counting. That's it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 14, 15. So once you get all 15 and they are in ascending order, then you can relax. Now, how do I represent this data using the stem plot? So what is stem plot? We
So,
have stem and leaf, right?
yes, sir.
So we will have there will be stem, and this is leaf. And leaf will contain only the last digit. Right? Even your number data points are some 10-digit numbers. All the 9 digits till the 10th unit, starting from the first digit till the 10th unit, it will go into the stem. And leaf will contain only the last entry. Right? So we have 12, 15, 17, 18 in tens. So our stem is 1, the tens unit is 1, and then we have 2, which represents 12, 15, 17, and 18. So stem is 1, and whatever the values that are there in the units digit, we will just write them in. Right? So hope all of you know this. So in the next stem 2, we'll have 20, 20, 22, 24, 25, 27. So 0, 0, 2, 4, 5, 7. Right, so then in 30s, the stem is 3, and we have 30, 30, 30, 32. Sorry? Somebody speaking?
No, sir, I was like 0, 0, 0, and 2 will go in leaf.
That's it. So 0, 0, 0, 2. And you can write 4 and just keep it empty. That is also possible. You just keep it empty. Or if you don't want to waste your space, then you can directly write 8, and there is 1 point. Okay. So this is the stem point. That's all this. Third one is histogram. Right. So histograms are used when the data points have a continuous values. Right. So here, since they are marks, score obtained by each of the student, they are continuing. So histogram has two axes, x and y axis, right? And we have this is 0. So this is 10, 20, 50, 70, and okay, then 80 and 90. Okay, so this side is the scores. This side will be the count, right? Or how many data points. So 0 to 10, there are no data points. And between 10 to 20, there are 12, 15, 17, and 18, 4 data points. So we'll have to construct a rectangle of height 4. And width will be the bin width. Bin is like we have taken 10 to 19, not 10 to 20, like this, right? So 10 units or 9 units. So whatever the bin we choose, that will be the width. And then the height is basically the number of data points. This is 4. And then what? From 20 to 30, there are 1, 2, 3, 4, 5, 6 data points. So now we have to construct a rectangle of height 6. And width will be the same. Right, so this will do 6. And then from 30 to 40, there are 4 data points. Again, it will do like this. And there is no data point between 40 to 50, 50 to 60, 60 to 70, 70 to 80. Everything will be 0. There will not be any bars or rectangles. And then finally between 80 to 90, there is one data point. Like this. Right, so this is the histogram. This is how we should plot the histogram. And I hope if most of you have plotted, this is how the graph looks, right? So this is correct. Any difference in your plotting?
Sir, I have a question.
Yes.
Sir, so instead of leaving the middle part blank, can we just write the last category as 40 and above and just put 1 there?
Okay, so these are not categories, right? So something like, see, these are not bar graphs. You put them into categories and then plot each of them into categories. We asked you to plot the histogram, right? So I should have said this clearly. It's not 40 above. It's basically 82, 89. See, basically histograms, if you plot these rectangles, no, they will all be touching together. So it's like, these are not categories, these are continuous variable where it can take any possible value between 10 to 90. Okay, so therefore, if you want to show the exact scores or exact plot very nicely, this is how you should show. You should also show the distance between this guy and the others in the histogram. Whereas if you group them and say 10 to 20 group, 20 to 30 group, 30 to 40 group, and 40 above group. So it's like you are categorizing them into groups and then you are plotting. That becomes bar graph. Right, so there is a subtle difference between bar graph and histogram. So bar graph is plotted for discrete groups, discrete values or discrete groups. Okay, whereas histograms are plotted for continuous values.
Okay, sir. Got it. Thank
Got
you.
the difference, right? Yeah.
Yeah.
All right. So this is histogram, and then the later ones are the computation parts. We have to compute mean, median, mode. Okay, so mode we'll first find mode. So for fourth one, I'll just take data points. So some of you might be thinking that I'm going really slow, but you just let me know if I'm really slow. We will just pace this up. I want everybody to understand it clearly, so that is why I'm little slow. But if everybody is able to understand, please let me know. We will pace. I will increase the pace. Alright, so this is the data set that we have, which is sorted. If we have to find the mode, what is mode?
So mode is the maximum
30.
frequent. Yes, sir, 30.
Like which data value is repeated highest number of times?
30.
Ah,
So
30 should.
30.
30, correct, right? So the mode will be 30. It is very easy. Now coming to mean also is like you have the standard definition for mean. All you have to do is you add all the data points divided by
Number of observations.
which is 15 here. So did anybody do this computation?
Yes, sir.
What's the value?
That's 27.13. 13.
27.13. Okay, great. Now median is basically the value at which 50% of the data points are lesser than that and 50% data points are greater than. Right, so since this is an odd number of data points, we don't have to worry too much. Whatever the data point you choose, the left and right side should be equal number of data points. That's the easiest way to choose, or you can just find it by n plus 1 by 2. So since there are 15 data points, 15 plus 1 is 16, 16 by 2 is 8. Eighth data point is the
So
middle.
it's 24.
So 1, 2,
Yes, sir,
3, 4,
24.
5, 6, 7, 8 is 20. This is the middle data point, right? So it's 24. Now, if you see this data, which one do you think the best representation for of the data? Like if I'm talking about measure of central tendency, right? So if I want one value which actually describes the whole data set, is mode or mean or median looks better for you guys?
So I think mean is the
Median.
same.
Mean looks better, is it?
Yes, sir.
So do you think all the data points are concentrated, or does it look like 27.3 is something like on an average 27.3 is the marks scored by the students?
Sir,
Does
I
it
think
look like
median would be more like represent the weight.
So because if you see, there are candidates who got 12, 15, 17, 18, 20, 22, 24, 25, 27, 30, 30, 30, 32. So almost 14 data points are nearly close to 24 compared to 27.13. So if you take 27.13, 12, 15, 17 are little far, right? Like 15, 16
Yes,
units
sir.
fall. So compared to 24 and 27.13, 24 looks little better, and mean has been fluctuated because of one data point.
So due to the outlier, that is 85.
That is 85. 85 is, even from the histogram, if you see, most of the data is concentrated between 10 to 40, right? And 10, within 10 to 40, 25 or 24, which is the middle one, 24, 25, we think that is a good representative of center value, right? If I just exclude that 80, 85, right? So it should look like that. But whereas mean has shifted towards right because of that data point 85. So that is why mean is changed, or mean gets fluctuated because of outliers, whereas median will not. So median is always the center value. No matter how many data points you have, or no matter what data point values are, it is exactly the center. Sometimes median also fails, right? So sometimes median may not be a good representative, and mean is much better. So that is also there, and yeah, that I wanted to emphasize it here. Let's move on. Let's compute. Let's move on to the next question, which is
Q1, Q2,
calculating
and
Q1,
Q3.
Q2, Q3. So Q2 is very easy again. So Q2 is basically, since I have taken 15 data points, Q2 is nothing but our median value,
24.
which is 24. Now Q1, for Q1, I have to find the value of NP, right? So Q1 is basically the 25th percentile. So what does it mean? At least 25% of the data should be lesser than Q1, right? So you have 15 data points. Okay, so if you compute the 25% of the 15 data points, what do you think will be? So 50th is 8. 25 will be,
So it's, I think, fourth position of the ascending order.
right? Or if you are a little confused, you compute, if you want only the formulas, you compute the p-value from here. P is basically 0.25,
0.25.
which is like 25 by 100, which is 0.25. Then compute NP, which is nothing but saying if you have 100 data points, compute the 25th data point. That's it. So n times p gives me the 25th data point. So n is 15 here. 15 times 0.25 is 3.75. So 3.75, the data point will not be there, right? So data points are integers, or more specific, natural numbers. So 3.75 data point we cannot find. So we have to choose the fourth data point, because if I choose the third data point, that data, if I look at the left hand side or lesser than that, it will not be 25 percentile. So you will only have 2 data points which is lesser than 25 percentile. So Q1 actually tells us Q1, whatever the data point that we are going to choose as Q1, there is 25%, at least 25 percentile of the data points are lesser than that Q1, at least. Okay, so that is why we choose the next data point or next observation, which is fourth data point will be Q. Okay, so that is Q1, which is 18. Okay, so if fourth data point is Q1, without computing, can you all say which data point will be Q3? Any strong guesses?
30.
30,
30 and
11th
which
one,
place? Which place?
11th place.
15, 14, 13, 12, 11. This one.
Yes,
So 12th place, I
12th
think.
one.
12th place. See, you see, this 25th percentile and 75 percentile will be symmetric to each other from the center.
sorry,
Okay.
sorry.
If your fourth data point is Q1, then from the right hand side, the fourth data point will be Q3. Okay, think of this like a trick or whatever, shortcut or whatever. You don't have to sit and compute n times p, where p is 0.75 again. So you can compute and see also. I don't stop you to compute. But if you compute 15 times 0.75, so which is 15 times 3 by 4, which is 45 by 4, which will be 11.25, right? So the next data point will be 12th.
Sir, I have a question.
Hmm.
Like if we get 11.01 as the value,
Even then you have to choose the right side.
okay.
Because as I was saying, right? So 11.01, the data point will be the data point with which 75 percentile of data is lesser than that. If you choose 11, then 75% of the data will not be lesser than that. Right? So we need at least 75%. So since it is coming at 11.01, so we need at least, right? So we have to move, you should always move on towards the right side only. If you move towards the left side, it will go lesser than 75, which we don't, which is not Q3.
Okay, got it. Thank you.
Okay. So we have Q3. Q3 is 30. Right. So this is Q1. This is Q3. And we also have Q2. So once we have all this, also we have a minimum maximum also. Minimum is 12. When you sort it, now the first data point will be the minimum value, the last data point will be the maximum value. So we have the 5-number summary with this. So then we have to find IQR. So the interquartile range will be Q3 minus Q1, which is 30 minus 18 is 12. Once we have this IQR, then we have to compute the outliers. So outliers are basically, what is an outlier? Outlier. So it is lying outside, right? So which are the data points that are lying outside? How do I say which data points are outside or inside? For that, we have this kind of formula, and this is not sacred formula. Okay, so you should always, I am not saying that you should always use this. This is one way of identifying or saying a particular data point is outlier. That is, you have Q1 with you, you have Q2 with you, Q3 with you. So there are 25% observations to the left of Q1, and there are 25% observations right of Q3, and the center has 50%. So Q1 to Q3 has 50% of the data. Right? So now, since the center is between Q1 and Q3, these will not be outliers, these are inside. Okay, so any data point between Q1 and Q3 is inside one. Right? So you don't have to worry about this. Now the outliers are the data points which are far to the right of Q3 and far to the left of Q1. So how far is in our hands? Basically, it's in our hands. We can define how far. And here we, in general, or this is given by some author, I forgot his name, sorry. but so some mathematician, he has given this. So he said, since we have this interquartile range with us, I will not, so I will choose one place. Below that is an outlier. So what is that place is, I will subtract, I will take 1.5 times of this IQR. Okay. I'll take 1.5 times of this IQR and I just go to the left of Q1. Okay, so I will just go 1.5 times of IQR to the left and 1.5 times of IQR to the right. Anything within them is not an outlier. So this is IQR. Oh, this is not up to scale. Okay, so don't get confused. So this is IQR and I multiply this with 1.5. So I will take this whole length as well as some 0.5 times of it, more than like 1.5 times of it, and I will go towards the right side and I will mark my border to the right side of Q3 and I will mark my border. And similarly, on the left side also, I will go 1.5 times of IQR to the left of Q1. To the left of Q1. And I will mark my border. So anything within this range is inside. Anything outside this is an out. Okay, understood?
So can you repeat the seventh number question once again, because
Which one? Which one?
so
Sorry.
the last one.
Okay. So when I was not convinced by myself, okay, let's do this. So let's say this is Q1. This is Q3. Okay.
Yes.
And this is 50% of the data lies in between Q1 and Q3, and anything lying in between Q1 and Q3 are inside data points only, within the limits. Okay, so they are not outliers. And outliers are basically something to the right of Q3 and something to the left of Q1. And there will be data points that are close to Q3 also, and there will be data points that are far away from Q3 also. Where should I set this bar? Right, where should I set a value such that anything below that is within inside and anything above that is an outlier? Where should I set depends on this IQR. So this is IQR, right? So we will take 1.5 times of IQR length. Not just IQR, we are still giving 50% more. Okay, so we'll say 1.5 times of IQR to the right of Q3 is also within the range. So that means anything inside this is an insider, not an outlier. Okay, so Q3 plus 1.5 times of IQR. If any data point is more than that, then that is an outlier. Okay, so an outlier is anything greater than Q3 plus 1.5 times IQR is an outlier. It's called an outlier.
Yes.
Similarly, to the left side also, anything to the left of Q1, far away from Q1 to the left, is also an outlier. And how far? It is this side also, we are only allowing 1.5 times of IQR. So if IQR is 10, then we will allow 15 units to the right of Q3 and 15 units to the left of Q1. That's it. Those are the within the reach. Anything lesser than that or greater than this will be an outlier. So this is also set, and anything within this is an insider. Any data point above this or any data point below this is an outlier. So this is Q3 plus 1.5 times IQR, and this is Q1 minus 1.5 times IQR, because it is going towards left, right? So we have to subtract. So anything lesser than this or greater than this is an outlier. Okay, so now you understood
Yes, sir.
the outliers.
Yes, sir.
Oh. So that is an outlier. So here also, in order to find the outliers, we have to compute two things. One is Q3 plus 1.5 times IQR, another one is Q1 minus 1.5 times IQ. So we'll compute both. Q3 we have, Q3 is 30, right? So Q3 plus 1.5 times IQR is, Q3 is 30 plus 1.5 times IQR is 12. So this is 30 times 18, 30 plus 18, which is 48. So it's like 48 is the max limit. So anything below 48, we say within insiders. So they are our people. So they are allowed into our home. Anything above 48, they are not allowed. Right? So
Yes, sir.
this happens, right? If we are in college, if we are getting some marks around 60 or 70, or our friends also, we expect to get around that marks, right? So if we are getting 40 or 50 and somebody is getting 70, 80, we won't accept, right? We won't accept them. We will say he's an outlier. He won't come within our study group or something.
Sir, I have a question. For the
Hmm.
second condition, the outlier will be less than Q1, right?
It should be less than Q1 only, right? Only then it will be left of Q1, right?
Yeah, the left one.
Right.
So
Sorry, sir. It should be lesser than, correct. Thanks. So we'll also compute this Q1 minus 1.5 times IQR. So Q1 is 18
That is 0.
minus 1.5 times 12, which is 18 minus 18. That is 0. Okay, so all our data points, any data point that is lesser than 0, so greater than 48 or lesser than 0, so anything greater than 48 or lesser than 0 are outliers. If you see our data points, it is starting from 12. So there is no data point that is lesser than 0. But there is a data point that is greater than 48, which is 85. So the number of outliers are 1, and that is 85. Right? So, yeah. And these are really important, okay? Calculating Q1, Q2, Q3, computing mean, median, mode. And then from the stem plot, how do you represent or write down the data explicitly? Or given the data, how do you represent the data using the stem plot? And also the histograms and everything. And IQR, you have to compute IQR. And you should know IQR is Q3 minus Q1. We are not going to give any formulas, okay? So you should know at least these things. And then outliers, we will define. We might give you some other formulas also, okay? So it's not as that is why I said, if we said the outlier is something Q1 minus 2 times of IQR and Q3 is another outlier is Q3 plus 2 times of IQR, then you have to compute according to that. Okay, you should not come and say that you have given the formula incorrect. Okay, so depending upon the outlier definition that we define, you should compute the outliers. Okay, All right, so if there aren't any doubts on that particular topic, let's strain our mental ability. I would like to give one puzzle which will refresh our brains. Then we can get back to. If any doubts related to week 3, we can. There are no doubts, then I'll give you something which is interesting, more interesting. Any doubts?
Excuse me, sir.
No, sir.
How's the
Yes,
Sir, I have a doubt.
Hmm.
Can I ask it?
Yeah.
So in median, if the number of observations is even, we take the average of the n by 2th and n plus 1 by 2th.
Hmm.
So does it apply for the quartiles or not?
No, just now I said, right? I have answered the exact question. It will not apply basically. Because for quartiles, no, you should definitely choose a data point.
Okay, sir.
But for median value, it need not be a data point.
Okay. So if it is a 50%, then it is just going to be the data point. Whereas if it is a median, only then it's the average.
Right.
Thank you, sir.
Okay. Any other doubts?
Yes, I have doubts from practice assignment, question number 8 and 9.
Which practice assignment? 3.1 or 3.2?
So it's 3.1,
3.1, 8.
8 and 9.
Okay. Okay, so I'll take that. But before that, they said, try this out, no? Hey. Okay. Is my screen visible still?
Yes, sir.
Alright, so- Happened to my pen. All right. Okay, so all right, let's say you have 5 circles with you, okay? And question is, or the challenge is, you have to draw one straight line, like one straight line, which will exactly divide the area of these circles. No, you have different areas, right? So to the left of this line and to the right of this line, the area should be equal. Okay, I hope the question is clear. So all you have to do is you have to draw a straight line where that gray colored area is there, no? So the gray colored area should be equally split, right? So try this out if you, as I said, this is nothing to do with any statistics or anything related to it. Just because I thought we are continuously discussing for 1.5 hours, just to refresh the scale. Okay, so try it out. Let me know if you got any answers. Meanwhile, I will just discuss this 8 and 9 problems in practice assignment 3.0. Okay. Maybe I will number this. Let's say this is puzzle 1. Throughout our journey, I'll try to give some brainstorming puzzles. Okay. Okay, all right. So this question 8, we have been given that the mean of n observations is 15. Right, and the mean of two n observations x2n, then verbally xn plus 1 and so on, x2n is 45, and then mean of 3n observations x1 x2 to xn plus 1 to x2n plus 1 till x3n is 34. Right, so then what is the mean of, question is, what is the mean of 2 times xn plus 1 is 2 times xn plus 2 and so on, plus 2 times x2n. Oh, it's not plus, it's the answer, it's the data point. There's this 2xn and 3x2n plus 1 and 3x2n plus 2 and 3x3. Right, so this is mean we have to find. So we have been given 3 pieces of information basically. From here, I know x1 plus x2 till xn divided by n is 50. Correct?
Yes, sir.
So from here, I know the sum till n, which is 59. We just multiply n to the right side. That's it. Right?
Yes, sir.
Now, from the second information, I'll just number this equation as well. From the second information, I have x1 plus x2 plus x3 and so on xn. Then xn plus 1 till x2n. And how many data points this time?
2n data point, I think.
2n data points, which is 45. Correct?
Yes, sir.
So from here, really sorry, I think pen is behaving oddly because of charge. Okay. So from here, I'll get the sum till x2n, which is 2n times 45 or 90.
Tn, yes, sir.
Correct. Good. Okay, we'll come to the third information, but from the first two informations, I know the first n data point sum is 15n, and I know the whole 2n data point sum is 90n. Can I compute the sum from xn plus 1 to x2n from these two?
So something like you are talking about like 15n plus 19n, 90n is equal to 34.
No. So Okay, I will write it here. So I have this value, which is 15n, correct?
Yes, sir.
I also have this value x1 plus x2 plus xn plus 1 plus and so on x2n. This is 90n,
Yes, sir.
correct? So I have this sum. What is this sum? x1 to xn.
Xn, yes, sir.
This is 15n because
Yes,
from
sir.
this. So if I substitute that as 15n, then I take that 15n to the right hand side. I'll get
Okay.
this sum xn plus 1, xn plus 2, and so on till x2n, which is
75.
75n. Let's say this is equation 3. Okay.
Yes, sir.
Now I will come to the last. So from x1 to x3n, the mean is 34. What does that information tell us? That tells us that x1 plus x2 till x3n divided by 3n is 34.
Yes, sir.
Correct. So from here, I can get the sum from x1 till x3n,
3n is 34
which
into
is
3n.
34 into 3, which is 102n.
So I think 102n.
102n, correct? So you call this as equation 4 or whatever. But what we have now, we have x1 plus x2, not only till xn, and then also xn plus 1, xn plus 2, till not till only x2n. Then we have x2n plus 1 plus and so on till x3n, which is 102n. Correct?
Yes, sir.
So we have this whole sum x1 till x2n.
Yeah.
What is that sum equals to?
It's 15n this side and this side 2n. That is, I think, 90n something.
So starting from x1 till x2n. So this
105.
no, you see this. No?
Oh, yes, sir.
It is starting from x1 to x2n, right?
Yes, sir.
And that is 90n. If this is 90n, then I can write down this sum x2n plus 1 se leke till x3n. What will this be? 102n minus 90n.
That's 90n.
Correct. So 90n plus this sum is 102n.
It's like, can you go to the above page, because some portion is yeah, so just do it. X1 plus x2 plus xn to 15. Yeah. Yes, sir. Now, okay.
Correct, right?
Yeah, that's true. The last step is okay. No problem, sir.
Correct, right? So this will be 12n. I will call this as equation 4 or 5. So now carefully see equation 3 and 5. So we have sum from n plus 1 to 2n and 2n plus 1 to 3n. Correct?
Yes, sir.
The question is, what is the mean of 2xn plus 1, 2xn plus 2 and so on 2x2n and 3xn 3x2n plus 1, 3x2n plus 2 and so on. So what is the mean of that? Mean of that is 2xn plus 1 plus 2xn plus 2 and so on 2x2n plus 3 times x2n plus 1 plus 3 times x2n plus 2 and 3x3n. And how many data points are there here? Xn n plus 1s till 3n.
n plus 1 till 3n.
How many?
N plus 1. So that will be, I think, 3n. 3n minus n minus 1. That means 2n minus 1.
Okay. So why 2n minus 1?
So because I'm taking the rightmost, that is 3n, and the first one, that is n plus
No.
1. If we
I know. I think you got one less. You see this way, no? From n plus 1 to 2n. How many data points are this?
it's 2n.
No, n plus 1 to 2n. Not
N
from
plus
starting.
1.
Okay, you write this 2n as n plus n. 2n is n plus n, no? So from
sir.
starting from n plus 1 till n plus n, how many data points are there? N plus 1, n plus 2, n plus 3 till n plus n.
Is it n minus 1?
No, right? So okay, so okay, you drop this n if you are too confused. See this n plus 1, n plus 2 till n plus n. Starting from plus 1 till plus n. So 1, 2, 3, 4, 5, 6, 7 till n. How many will be there?
N.
N, right? So you see these. This is plus 1. You think plus 1 as first data point. Plus 2 as second. Plus 3 will be third. And so on. Plus n will be nth.
Int, yes, sir.
Right? So similarly, here also you can see in that same way. Plus 1, plus 2, and 3n you can write it as 2n plus n. Right?
Yes, sir.
So these are n observations. And these are n observations. Totally, there are 2n observations.
2n observations, yes, sir.
So mean will be this. Now you can take 2 common from the first n observations. And the sum is nothing but xn plus 1 till x2n. And you can take 3 common. And then the sum will be from x2n plus 1, so okay, x3 divided by 2. Right, so this xn plus 1 till x2n will come from equation 3. So xn plus 1 till x2n sum, we know that it is 75. Right?
Yes, sir.
So this is
2 into 75.
This is 75.
75, yes, sir.
And this is from equation 5. So 2n plus 1 till 3n, which is 12n. Right?
Yes, sir.
So now this will be 2 times 75n plus 3 times 12 divided by 12. Now all n will be cancelled out. And then we just have to compute it. 2 times 75 is 150 plus 3 times 12 is 36 divided by 2. So 186 by 2, which is 93. Okay.
Yes, sir.
So it is basically the whole total data points are split into 3 groups. Right. So first n mean they have given us. Next till 2n mean they have given us. And then till 3n mean they have given us. Something like you have 30 observations. Then the first 10 observations mean given to us. Then first 20 observations mean is given to us. Then the whole 30 observations mean is given to us. Then they are asking the mean of 2 times the 11th observation, 2 times the 12th observation, till 2 times the 20th observation, and 3 times the 21st observation, 3 times the 22nd observation, till 3 times the 30th observation. So if there are any variables like this, no, some n variables, if you are getting confused, take a random value for n. Fix it to be something 3. Simplest one is 3. Put n to be 3. If n is 3, then It is very, very, very easy. So the first 3 observations mean is 15. Next, the 6 observations mean is 45. Next, 9 observations mean is 34. Then they are asking 2 times x4, 2 times x5, 2 times x6, 3 times x7, 3 times x8, 3 times x9's mean. Okay.
Yes, sir.
Or want to be very easy. Choose n to be 1. Okay, so if n is 1, then what does it mean? X1, only one observation. X1 is 15. And then x1, x2 mean is 45. Then x1, x2, x3 mean is 34. Right? So x1 plus x2 by 2 is 45. So from here x1 plus x2 is 90. From here x2 is 75 because x1 is 50. And x1, x2, x3. So these are some, not the mathematical ways, okay, some easy ways to do, some shortcuts. So these shortcuts or tricks or whatever you call comes from improving your critical thinking. And one best way to improve your critical thinking is to solve puzzles. Okay. So when you're good at solving puzzles, your critical thinking will be improved. And once this way, if you start thinking in this way, no, statistics or mathematics or understanding them will be easier and solving them will also be fun and easier. Okay, so you can use this and you can also compute. Finally, you will get the same value. I think 93. You can try it out. Okay.
Yes, sir. Sir, is there like after completing this class, is there any way like I got the PDF of this class note?
Yeah, I think I will share this to one of the other instructors. I think they will upload it. Okay.
So actually, where will I be able to get the
It will
PDF?
be in supplementary contents, no? So we'll give you live session notes, live session slides or notes. In that we will upload.
Okay, sir.
All right, so we are almost end towards 8 p.m. This is the final 10 minutes for week 3. If you still have any doubts, you can ask. Or if you find the answer for this puzzle, you can also post it in discussion forum or discourses if you are foundational. Okay, so I'm not going to reveal any of the puzzle solutions. Okay, so it is up to you to figure it out. Maybe by the maybe after quiz 1, if at all we are relaxed a bit there, I'll just reveal some of the puzzle solutions. Okay, so I hope whatever we discussed today that clears most of the doubts in week 3, and we'll meet next week. Okay.
Yes, sir.
Yes, sir.
All right then. Thanks all guys for joining and have a great day.
Thank you, sir.
Yeah. Bye.